Hey friends, welcome back to Mocktail Studio. In today's video, we are diving into unit testing with Mocktail. If you're new to testing or even new to Flutter, I'll walk you through everything step by step. We'll build a simple app, write tests for it, and understand how Mocktail helps us pick dependencies. Let's get started. We're going to build a super simple app, a tip calculator. It takes a bill amount and a tip percentage and calculates the total tip. The calculation logic will be in a separate service class, so we can write tests for it in isolation. First, let's set up a new Flutter project by running the command flutter create. Then you can proceed to give the name of your project. Then we'll proceed to add the Mocktail package by running flutter pub add Mocktail. So I'm currently using the version 1.0.4. Great. Before we start writing our mock class, let's take a moment to understand what Mocktail actually is and why it's so useful in testing. Mocktail is a Dart package used in unit testing. Think of it as a tool that helps you create mock versions of your classes and functions. When we say Mocktail is a Dart package, it means it's built specifically for Dart and Flutter apps. It makes unit testing easier by allowing you to fake real objects. In basic programming, an object is an instance of a class, meaning it contains properties and methods. So think of a class as a blueprint, like building a car, how to build a car, and then the object is the actual car built from that blueprint. So instead of manually writing dummy classes, Mocktail lets you automate the creation of mocks. You don't need to worry about implementing every method, it handles that for you. Mocking means Mocktail allows you to simulate the behavior of the service class without actually performing any, in our case, tip calculation. This is useful for testing, especially when the service might depend on something external like a database or an API. So mocks let your test pretend it's working with something real like an API or a database, but without actually using them. So this means you can run your tests quickly, safely, and also offline. You may have heard the word stubbing. So what it means, it's controlling what the mock should do or should return when a method is called. So it uses there are two stub methods that Mocktail uses, which is when and then return. So this lets you focus on testing your app's logic rather than the actual implementation of the service. So you're controlling and saying that this mock should return this specific value when this specific method is returned. Some of the benefits of mocks is that your test won't break if the API goes down or the database changes. Also, you get to decide exactly what the mock should return or do. And lastly, you'll get the same result every time. There won't be random errors. Now that we know what Mocktail is, let's go ahead and use it in our tip calculator app. So let's write the app logic. We'll start by creating an abstract class called tip calculator service. So our abstract class, basically an abstract class is a class that does not provide any implementation, just method declarations. So we're declaring a few methods here, specifically 3. So we'll have the calculate tip. This method will help us to calculate the tip based on the amount and the tip percentage that has been passed in the function. Then we'll have the get tip history. This method will help us get the history of saved tips and returns a future containing a list of doubles representing the saved tips. Then we'll have a save tip, which is the method that we'll use to save a tip to a history. And when I say history, it means you can save it in a local database, in a memory cache, or even in an external database that's either Postgres or MySQL. So, and in this case, we'll make sure it does not return anything. That's why we're setting this as void. Now let's create our class that is called tip calculator service IMPL, which now will be the implementation of the abstract class that we have defined, and will provide the actual functionality, starting with the calculate tip. So the formula to calculate a tip will be amount times tip percentage time divide by 100. So this is how it is, and then we return the result out of this calculation. Then the next function will be get tip history, and this will just simulate an API call to get a list of previously saved tips. So we're using the future.delay to mock or to simulate a network delay and we're making it as a placeholder to mimic the delay that would occur if you were using a real API call. So this is where we would set an API call to access either a database in this case, but now we're going to use a future delay for that to just simulate that, and then we return static data, which is 100 and 150. So this is a predefined list of the tips. Then lastly, we have another function, save tip. We'll also do the same concept where we simulate a network delay for saving the tip, and since it's a void, we're not returning anything. But remember, in a real case scenario, these tips will be saved to a database or a remote API, and we'll need to call them from there. But since this is a simulation, there's no actual storage happening. We're just using future delay to simulate that scenario. Great. Now let's proceed to create our unit tests. So we need to have a folder called tests, specific test, TEST, and then inside it we have a file called tip calculator service test, and inside here is where we're creating our unit tests. So we'll need to create a mock class, and by doing that we'll define a class called mock tip calculator service and extend the mock, which will get it from the mocktail package, and implement our service, which is a tip calculator service that we just talked about. So all that we're doing is just, the reason why we're implementing this, we're simulating the behavior of the actual service without hitting the real service itself. So we're accessing the methods that are there together with the methods that are there. Great. So now we'll start by void, the main function. This is the entry point. So we set up the mock and the stub methods that we need. But first we need to create a variable that will hold our mocked service instance, which is this. This is our instance. Here it is. And then now we're going to, in our setup, setup means this method, what it does in testing, in Flutter test, it runs before each test in the group that we're going to define. So it will always run whenever a test has been done. It will run whatever logic is inside it, and then before each test, and then it runs this test. Whatever logic is inside here, it runs, and then it executes the next test. So that's what happens in setup. So if you need any initialization done before each test, this is where you put your code. Great. Now let's look at our group. So it's efficient to actually group related tests together just for better organization and readability. So we call our group tip calculator service test, and then now we start defining our test. Our first test will be should calculate tip correctly using the mock service. So this test is to check if the calculator tip method that we have in our service returns the correct value from the mocked service, because we've already mocked a service that is equivalent to whatever service that we have here. So we start with a when, which is just one of the stub methods. So we say when, and then we proceed to call our instance, and then we go and retrieve the method calculate tip. Then we pass in the arguments that are needed, which is amount and the tip percentage, and we are setting that the return or the mocked result that we want it to return, which is 10, which is actually accurate. Then we're going to define another variable to test the method with the mocked service. So we're going to define another variable here, and then we call the same method using the instance, and it will initialize the result on this variable. So what we're doing now, which is the next step, is to test whether the method in the mocked service is working correctly. So we are expecting this tip to be equal to 10.0. So if it ends up being any other value, then there's a fail. or the test has failed. So we are asserting that the result returned by the method matches the mock-to value, which is 10.0. So simply, this is one of the tests that we have done. The next test is should call calculator tip method once. So we're using the when stub method again, and then we're doing the same thing. We're calling this method and returning a value, and then we just execute this by saying we're calling the instance and calling this calculate tip. Then we want to check whether when calling this calculate tip it executed this call once or did it execute it twice. So what happens here, we are in the when stub method, we are mocking the calculation but with different parameters. Okay, then now we proceed now to call the method from our mock service, and now we want to check by calling this, does it execute it once or twice? It should be once. If it's once, the verify method should return true, like it's correct. It should return one. If it's once, the test will be successful. Else, if it turns true for some reason that the method is being executed twice, it will fail. So that's why you see, that's why you can implement verify stub to verify that the the call has been done and it has been done once. Another test case will be to check if to fetch tips from the service. So we predefine a variable that called tips that returns a list of 120.0 and 100. They're of type double. And then again we proceed to mock this new method from the instance. So we in this specific logic, we're calling the instance of the class of our mock service, and then we are mocking this specific logic in this method, and then we are saying then answer, return the specific tips that we have predefined here. So to check if we're correct now, we're calling a variable, we're defining a variable called result and going ahead to call it straight ahead, and we're expecting that the result that we get here will be equivalent to the number of the variable called tips, the result or the values inside the tips list. And then another thing we're doing is using the verify method also to check that the call has been done once, the call has been made, and also the call has been made once. So that's how to use the 3 stub methods. And also the expect is found in the Flutter test, so that is also important. So the next one is we are checking fetching tips from the service. Then the last one will be now adding a tip. So for adding a tip, you remember we are not returning anything, but we'll just mock the save tip method from our service, and then make sure that we are setting future.value. We're returning a future just to mimic that the tip has been saved asynchronously, for example. So this is what helps us mock the service from our service class. And then now we proceed to call it, and we expect it to return 40. We are saving a tip, the tip is 40, so we're proceeding to save it. And then now we verify that the call has been made, this specific call where the parameter is 40, and also it has been called only once. So that's how we have decided to implement Mocktail. So we have 4 tests that we have done. Now we need to check whether the tests are successful or not. So I'll proceed to the terminal, and all you have to do is run the command flutter test, and all the tests have passed. So let's try another scenario where in our first test should calculate tip correctly using the mock service. Let me try and change this to maybe 15. You'll expect a fail because what is expected is actually 10, but what's being returned is 15 when we compare or when we assert. Okay, so you can see our unit tests are actually working. What else can we test? We can test The same thing will happen in this test. Let me check for something else. If we change the values here as well, maybe, because this is just fetching tips, it will still fail if we change. I'm trying to look for any unique, yeah, it's basically that. So you can see that you can actually check, but if I set a value to a certain thing and then maybe the calculation, the implementation in the calculate tip produces a different response. We're saying what we're expecting to be returned is 15, but now when the actual calculation is done from this method, it returns a different value. Obviously, the unit test will fail, so it will give a more reason to actually look at either the method, the implementation done, what could be wrong, because that's what testing is all about, to check if our app logic is working as it should. Now, some of the tips for using Mocktail, which are not many to be honest, is just always use verify if you want to be sure something was called. As you can see, we are checking, as I mentioned earlier, that's what we're using verify for in this unit cases. Like here, we're making sure that this call has been made and it has been made once. And then there's a special matcher called any that you can use to represent any value that could be passed as an argument. So if you don't want to specify the data type, you can use any for that. And then obviously the last one will be avoid overmocking, because if you mock or too many parts of your code, especially when testing, you'll find that you might end up testing things that aren't real or meaningful. So not everything should be mocked. Just if you can focus on mainly the app logic part. If you want to test your widgets or your UI, you can use widget tests instead. But Mocktail is mainly efficient for like the actual logic, the implementation, and specific parts. It has to be realistic as well. So maybe some of you might be curious that we have regular unit tests that we can create using Flutter test, and then we have Mocktail. So what's the difference? I would say with regular unit tests, you typically rely on real implementations of dependencies. For example, if your service depends on a database or an API, the unit test would call the real database or API. While in Mocktail, as you have seen, we allow you to mock dependencies to simulate that real-world behavior without actually interacting with the real external systems or databases, APIs, and the like. So we're replacing those dependencies with mock objects. As you can see, this is a mock object. Wait. Another thing I would mention is that when tests rely on external dependencies, you'll find that there's that state of unreliability, where if the external service is down, then it's very hard to actually test the actual case. But with Mocktail, since it's offline, it's more reliable because you're simulating everything in a situation where you can test everything offline. You have full control of the return values for the various methods, and you can also simulate different scenarios. As you have seen, we have simulated the scenario where we are accessing something from the API or from the database. So let's look at let's do a quick recap. So we've just looked at what Mocktail is and how to create a mock class, as you can see, by extending the mock. And then we also have defined the different methods that are involved. Setup is part of Flutter test, so you don't only use it when using Mocktail. So it's a function that, as I said, runs before each test. Then we have looked at our stubbing methods, which is when, and then return, and also there's then answer. Then also we have used assertions. Assertion is where we are expecting this value to be equal to this value. They should be the same. And this you can find it in Flutter test. It doesn't only come with Mocktail. Wait. And also we've looked at verifying method calls. We verify if a method was called and how many times, which is important obviously. And also in terms of async testing, we have been able to use then answer to simulate async responses, as we saw in, where is it? Then return. I think we have it somewhere. then answer. Here it is. For async testing, as you can see, we used future.value. Great. And then test isolation. Mocking ensures that tests remain isolated and deterministic for the same reasons that we mentioned earlier. Another thing is that we've also looked at the difference between regular unit tests and using Mocktail, because you might be asking yourself, why would I use Mocktail instead of unit tests? I think now you have an idea of that. So if you found this video helpful, don't forget to like and subscribe. If you have any questions, feel free to drop them in the comments below. Until then, see you in the next one.